Autonomous vehicles allow transportation for people who are unable to drive due to their age and physical condition, and they reduce the amount of collisions. 94% of accidents are caused by human error. They also reduce demand on emergency response systems, auto insurance, and healthcare costs. These vehicles use 3 different technologies: sensors, connectivity, and software and control algorithms. Sensors are used in features such as blind spot monitoring, lane keeping assistance, and forward collision warning. It uses radar, ultrasonics, and cameras to provide the necessary input to navigate the car safely. Connectivity has access to the latest traffic, weather, surface conditions, constructions, maps, adjacent cars, and road infrastructure. Data is then used to monitor a car's surrounding operating environment to anticipate braking or avoid hazardous conditions. Software and control algorithms are needed to reliably capture data from sensors and connectivity in order to make decisions on steering, braking, speed, and road guidance. Here, we have an example of an algorithm that is used to determine the acceleration. These are the typical values for factors that determine the acceleration model parameters for a car model of Teleport. And these are the acceleration model parameters for IDM. This is the intelligent driver model that assumes a velocity difference, the acceleration is a continuous function of the velocity, and the gap is a safe time headway. Here we have a tendency to accelerate and a tendency to decelerate. This is a desired gap between the 2 cars. What affects transport demands and costs? Demographic trends. There is a reduced number in used driver's licenses. This is due to increased urban living and rising fuel prices. There's increased carpooling and expanded system operations. Therefore, we have intelligent transport systems. Improved navigation and electronic pricing results in autonomous vehicles. In the cars we use today, we have semi-autonomous features, which may include assisted parking and self-braking systems, which is nice, but not everything is always picked up. Also, in vehicles such as a Jeep, there have been reports of hackers breaking into the control area network. The control area network is a car's internal communication system which carries information between various electronic control units. ECUs control steering, brakes, and parking, which when interfered with, can monitor and control what a car is doing. How do we hack a Jeep? Through legitimate operations. Telematics establishes productivity, expandability, safety, compliance, and fuel optimization. The gateway is where the malware is. This is software designed to cause damage to a network. Infotainment is information and entertainment. Ethics, empathetic, sympathetic, genetic, reduce stress, increase productivity, independent mobility, no more captivity, reduce costs, crashes, consumption, taking ownership, assumption, production, reduce security, additional risk. All this hacking just making me sick.